Hello, everyone. Good afternoon, dear authors and invited guests. It is my great pleasure to welcome you to the 6th International Congress on Information and Communication Technology through Zoom on behalf of ICICT 2021 and Global Knowledge Research Foundation. As every one of us is passing through unseen circumstances due to COVID-19, we wish everyone and their families a safe time, and we will together pass this soon. Further, with immense happiness, I would like to share with you that we have received an overwhelming response this year from across 90 countries, where 1,150 papers were received and 350 papers were accepted, contributing to the success of this conference, and the papers will be published in 4 volumes this year. We are thankful to all our guests present on this platform to join us digitally for the conference in these unpredictable times, and make this conference more fruitful in terms of technical knowledge, and hope you will enjoy the 2 days of their knowledgeful and interactive sessions. I would like to welcome you to this technical session 3E and further introduce you all to the chair for this session, Dr. Vijay Singh Rathore. He is a professor. Hello.
Yeah, good evening.
Good evening. He's a professor and director international at IIS University in Jaipur. Currently, he works at the Department of Computer Science and IT in IIS University. Professor Vijay Singh does research in information systems, business informatics, distributed computing, and databases. His last project was FICR TEAS 2020. Now we will start our presentations with Dr. Ala Shuwaikh, who will present towards Spark-based deep learning approach for fraud detection analysis. Dr. Ala, the floor is yours.
Hello, everyone.
Yes. Hello.
Yeah, hello.
Hello. So let me share my screen.
Yes.
Yeah, please let me know if you can see my screen.
Yes, we can.
Yes, so everyone, thanks for your presentation, Mohamed. So my work is about presenting a Spark-based deep learning approach for fraud detection analysis. So basically, my name is Shuwaikh Ali. So I'm from IMPT, Rabat, Morocco. So the outline of this presentation will be as follows. So we'll be starting with an introduction. I'll be presenting the data set that has been used during this work. Secondly, we'll be talking about the Spark-based proposed architecture. So we discuss the framework using deep learning approach. Secondly, we'll discuss the distributed training over the Spark. And the third part will be about the partial model training learning description. Then I will be presenting the experimental results within the proposed model, and then this real training implementation. And then we conclude with the discussions and future work. So as you know, the telecommunication is, a fast-growing industry worldwide. So, and the churn becomes a real concern for policymakers, and that's especially that the cost for customer acquisition, by the way, is 20 times greater than the cost of customer retention. So basically, we have several machine learning algorithms that has been used previously in the state of the art. And those machine learning address the churn problem using different features and different techniques. And basically, the question that we ask all the time about this topic is, what is the best predictive model that can bring much more accuracy or much more performance, depending on what we are trying to achieve from business perspective. So that data set that has been used during this work. So it has been obtained from Moroccan telecommunication provider. So it's a real data set. So here we are talking about 3-month customers' behavior and the customer data records, including the calls, SMS, recharge data sets, data CDRs, subscribed services for each given subscriber. So here we're talking only about the prepaid subscribers only, and the overall data set include 2.5 million customers, including basically churners and non-churners. So our proposed fraud detection framework is as follow. So we have the data which is coming from the BSS. The BSS is the business service support and telecommunication context. And we have a lot of events coming from this BSS that is feeding our database. So, and we are collecting the data set and feeding those data to our data sets, to our database, sorry. So this database basically contains all the data set that has been collected from different network elements in operator context. So we're doing some data set preparation. I mean, before basically feeding the data set to our Spark standalone cluster. So this data set preparation basically could be also removed from the architecture. I mean, we can include the data set directly to this standalone cluster. And then we have the final nodes, which is the classification parts, and then we can say if we have any fraudulent behavior or non-normal behavior. So basically here, just the main role here of the Spark platform is in the proposed framework is to tackling the volume. So when you have a lot of volume, so the Spark engine tackles the volumes as aspect by parallelizing basically the learning task into many subtasks, each performed on a small partition over the partition of the overall. So here I'm presenting our distributed deep learning training on Spark. So basically we have the Spark master node, we have different workers, and we have the partial model learning that has been distributed over the workers. So basically here each worker node compute the gradients updates of the data. So it's here the map reduce. And during this step, all the Spark basically execute basically the same map task. It's in parallel. So here, in order to speed up the learning. And in this way, basically, all the gradient computation task, which is costly and very expensive in terms of time. So of the deep model learning is divided basically into many parallel subtasks, and we can gain a lot of time during this process. So here we're talking about the partial model learning. So we can have just a small description. We have the master node, which is broadcasting the parameters to workers. We have the hyperparameter initialization. We have many hyperparameters. We are talking about momentum, weight, GD, and so on. So then we are doing the gradient computation. We can update parameters, and then we iterate until we have convergence of the model, and then we can get the partial model training. So our parameter setup as follows. So we have the mini batch size. It's 200K. The learning rate is 0.1. The optimization algorithm is SGD. The activation function is ReLU, and momentum 0.9. And the architecture uses basically 4 layers of 20 neurons each. So the results can be presented as follows. So basically, we had used the precision, the recall, the F1 score, and the learning duration. So for the model type, we can see it takes, for instance, 35 minutes for the learning duration. For the serial training implementation here, we have 221 minutes for the learning duration. And here we have different value for the precision and the recall and the F1 score. As I said, it's depend of what you are trying to achieve within the business. I mean, you can have a goal to achieve better precision or better recall or better accuracy. So it's depend on your need from business perspective. So here, in order to do some benchmarking using existing, traditional machine learning algorithms, we have used also the support vector machines. I've used the RF machine learning model. We have used our proposed model using the Spark based, and also the serial training implementation, which is not using any Spark implementation, and is the traditional manner of training deep learning models. So basically here we can see that training duration is, we achieved the best training duration using the proposed model, 35 minutes. Basically it's not the best, so we achieved much more results with the CVM and RF. But we can see that the training implementation is taking a lot of time. It's 221 minutes. And for the F1 score, we can see that our proposed model achieved the best F1 score percentage. So here what we can outline is as conclusions. So the deep learning algorithm basically is outperformed the conventional machine learning techniques, basically in terms of F1 score. And we can see that in this context, the Apache Spark, it performs basically very, very well using deep learning. We need to compare to the serial implementation without any parallel computing. So here we can see that we have a good learning speed. We have effective way to tackle fraud problem because it's the fraud duration, which is only 35 minutes. And basically it's excellent tool to detect early fraudulent events. So here during this work, we can say that the parameter tuning could be enhanced further and could be tweaked also further to improve the performance of our approach. So we can increase the number of cores results, because when we increase the number of cores, it results in quicker training of deep models. And then we can enhance this proposed framework by using much more cores in this work. And also basically this system can be integrated also to any big data analytics pipeline. So it will be a good thing that we can test in the future within this part. Thank you.
Okay, thank you for the good presentation. Any questions?
It was a very nice presentation. Let me congratulate you. Very nice.
Okay, if there are no questions then.
Yeah.
Anyone has any question?
If you can hear me.
Yes, we can.
Yes, just a very quick. Have you used Scala or PySpark? Just out of curiosity.
It's Scala basically.
Okay, thanks. Did you use Scala just because you thought it could be more efficient, or didn't you use Python? Is there a reason?
It's Python. Basically, it's just a choice, but I mean, both could be used and tested for this context.
Okay. Thanks.
You're welcome.
Thank you.
Just for the information, if the rest of the presenters have any questions, they can just drop message in the public chat forum or directly to the presenter for the queries or any questions. Yeah, thank you.
Thank you.
Okay. Now we move on to Dr. Vitaly Babenko, presenting Forming the System with the Functionality of Clinical Pharmacists for Personalized Treatment Strategy Searching. Dr. Vitaly, the floor is yours.
Okay, I'm hello, I'm demonstrating my screen.
Okay.
Can you see it?
Yes, we can.
Yeah, we can see.
Okay, so hello, dear colleagues. My name is Vitaly Babenko, and today I'm presenting to you the report named Forming the System with Functionality of Clinical Pharmacies for Personalized Treatment Strategy Searching. Ukrainian medicine is developing rapidly these days. First and foremost, the following began. The gradual use of modern treatment approaches, the use of international clinical protocols, which are constantly updated and carry the best practices and of recognized specialists, and also digital transformation, which will duly influence the state of modern medicine in our country. Unfortunately, it is still too early to say that these changes have had an appropriate impact on the overall picture. When it comes to clinical treatment, there is still the problem of the doctor deciding on the right strategy. Even if the clinical protocol is fully followed, it is possible that the chosen treatment is not fully optimal and that all symptoms or post-surgical complications haven't been treated. This can happen because doctors in their field do not have the full range of knowledge about all kinds of medicines and their usage. In this application rests with clinical pharmacists, of whom there are relatively few in Ukraine, and they are rarely found in medical institutions. Thus, it becomes necessary to create an informative system with the functionality of clinical pharmacists, which will be for the optimal treatment strategy search, which will be personalized due to physiological characteristics of the patient. This will fill the absence of clinical pharmacists in most medical institutions and will also ensure better decision making about clinical treatment for the patient. So problem statement, the patient's treatment process covers two states, initial and final. These states are characterized by certain medical indicators of a person. It can be represented as the following vectors. So we have vector X, which describes the initial state of patient, and vector Y, which describes the final state of the patient. The treatment strategy, which is applied to the patient, represented by a vector I, and it consists of influence parameters on the patient's state. As we can see from this image, vector Y directly depends on vectors X and I. It can be represented by the next equation. In other words, using the initial patient state parameters and influence parameters, it is possible to obtain machine learning models of the final state parameters. It can be both linear and non-linear parametric models, as well as non-parametric models, for example, decision tree or nearest neighbors. With their usage, it seems possible to modeling the treatment process. And thus, a multi-criteria optimization problem arises where it is necessary to find such values of vector I that will give the optimum of vector Y. Values of vector X are set by default, and that means that the personalized solution search will be made by taking into account the patient's initial state indicators. To solve this kind of multi-criteria optimization problem, we propose next algorithm. At first stage, we obviously select our medical data. Then we highlighting in this data the parameters of patient initial state, treatment, and patient final state. Then we making binarization of patient final state parameters. It means that we, for example, when we have heart rate of patient, we know that normal range of heart rate varies from 50 to 90 BPM. And we can say if heart rate of patient is normal, it's 0. In opposite way, it's 1. After this, after binarization, we're creating a metric to estimate the patient's state after treatment. For this, we're using analytic hierarchy process, which will be described later. Then we're modeling patient final state parameters using classification algorithm, and in the end, we finding treatment strategies that optimize patient final state by using a genetic algorithm. About analytic hierarchy process. We're using this to estimate to get our metric to estimate the patient's state after treatment. This is a solution of simultaneous optimization of patient final state parameters problem. The main idea of analytic hierarchy process is to link several criteria into one so-called super criterion with the help of additive convolution. Criteria in our case is the patient final state parameters. By using this method, firstly, we rank our criteria by their importance. And with this ranking, we're making the pairwise comparison table for our criteria. Each cell of this table has a priority value of one criterion among another. And then we calculate the geometric mean for each row of the table. After this, we can find weight for each our criterion by normalizing this geometric means, which give us our metric. This metric is the additive convolution function, which we need to optimize during our treatment searching. The signs in this formula are placed depending on whether it is necessary to maximize or minimize our criterion. For calculating criteria, we can use models obtained by the classification algorithm. About genetic algorithm, we have chosen it to solve NP complete problem in which we need to find the influence parameters values of vector I that give the global optimum, or more precisely, the maximum of additive convolution function. Since we link our patient final state parameters into this function, now we are solving the single criteria optimization problem, and genetic algorithm is one of the famous approaches to solve this problem. To describe this algorithm in more detail, at first stage, we creating a random population of individuals that contains values of vector I. Then we calculate for each individual our fitness function or additive convolution function. And then we checking our condition of algorithm end. If condition is complete, we stop our algorithm and choose the best individual. In opposite, we making genetic operators. Firstly, we doing selection. We are using Torrent selection. The approach is showing on this picture. Then we're using genetic operators such as crossover and mutation. And after these operations, we creating our new population and calculating the fitness function for individuals in this population. And we repeating these steps before our algorithm, our condition of the algorithm will be complete. So we try to use this approach in practical task. We chose a clinical database which describes the treatment of patients with congenital heart defects. It contains 144 patients from 1 to 18 years old. They underwent surgical operations, after which they were prescribed medication to eliminate postoperative complications. In total, the database has next 29 features and 10 patient initial state parameters, 10 influence parameters, and 9 final state parameters. To be able to solve this problem, the problem of searching personalized treatment strategy for a specifically selected base, it is necessary to obtain models of patient indicators after treatment by using the patient indicators before treatment and our influence parameters. To get models, we used a random forest classifier, which is one of the best choices for obtaining highly accurate prediction models.
You still have 2 minutes. Sorry.
Okay. As a result, we got 9 models of the patient's indicators after treatment by splitting the general data sample into training and testing. We evaluated by positive predict value, negative predict value, and accuracy. As you can see, we had very highly accurate models. After obtaining models, the pairwise comparison performed by using analytic hierarchy process, which made it possible to obtain the additive convolution function. Using these models, like this. And using this.
Sorry for the interruption. We just have 2 to 3 minutes left to complete the presentation.
Yeah, I understand. It's
yes, please. A bit fast.
Using these models and additive convolution function, we try to predict our treatment solution. And in comparison with a real-life treatment strategy, we can see that our treatment strategy gives better results. So here we have only 3 complications after treatment. So as a conclusion of our work, the algorithm was proposed for solving the task of searching a personalized treatment strategy. Algorithm consists of such methods as analytic hierarchy process, genetic algorithm, and random forest classifier. 9 models of patient indicators after treatment were obtained by random forest. The results can be used as the beginning of creating an informative system with the functionality of clinical pharmacists. It should be added that it is necessary to carefully elaborate on all stages of the system to provide effective support for the doctor in deciding on treatment strategy. In this way, the system will be able to fill the absence of clinical pharmacists and optimize the work of medical institutions. That's all. Thank you very much.
Thank you. Thank you for the informative presentation. Any questions?
Excuse me, I have a question. May I?
Yeah. Yes, of course.
Thank you. Thank you very much for your amazing presentation. I have 2 questions, if it's possible. First of all, I would like to know that this treatment is personalized for 1 patient or 10 patients?
It's personalized for 1 patient.
Okay, and my second question is, which method have you used for normalizing the history of the treatment? For example, text mining, NLP, how you normalize the treatment or the medical background of the patients?
You mean how we normalized?
Yes, which method? I mean, which method did you use the text mining or natural language processing, or you didn't go through this level to this phase?
We used the second one. Yeah.
The natural language processing.
Yeah.
Okay, and I think you didn't address which features did you use, which biological features did you use for this personalized treatment? Is it possible just to address if you use any, or maybe only administrative or medical history or any specific biological feature?
You asked about which medical, yes.
Yeah, which medical only, yes?
Mm-hmm. Yes, yes.
Okay, thank you very much. Thank you very much for your time.
Thank you too.
Thank you. Any more questions?
Now we should proceed, I think.
Hmm.
We can proceed further.
Okay, we'll proceed. Now, Dr. Rizhan Yu Pan presenting Intuitive Searching, an approach to search the decision policy of a blackjack agent. Dr. Rizhan Yu, the floor is yours.
Okay. Hello, everyone. Today I will introduce you an approach called intuitive search, which is used to search the decision policy of the blackjack game. To do so, I will display a 20 minutes pre-recorded video and using 3 minutes to answer your questions. Okay. Hello, everyone. I'm Zhen Yupan. Today, I will introduce you the intuitive search approach, which have been unwillingly used in our daily life. For example, when facing upcoming tests, we might collect some previous examinations and believe by solving all those problems, we can improve our score in tomorrow's examinations. In such example, the older examinations are our training sets. The ideology to answer each questions are the parameter. And there is an evaluation function f to tell the correctness of each question answering pair. The goal is to training the ideology so that the expectation of correctness can be maximum. The key idea is using the optimal solution of the training set as the approximation of the optimal solution of expectations. If we implement such idea on a classification problem, it brings us the decision tree, in which system parameter is a structure of the decision tree, and the evaluation function f represents the correctness of classification results. If we implement intuitive search on blackjack game, the training set will be a collection of card sequence. The decision system parameter and game result will be our evaluation function. In this paper, we are trying to answer a question where the optimal solution of training data set convergent to the optimal solution of the expectation when giving enough training data. To answer such question, we prove the correctness of intuitive search in blackjack agent case and study the experiment results. Then we turn our approach to a multidimensional case. In the end, we analyze the limitation of our approach. In this section, we begin with the rule of a simplified blackjack game. Then we introduce the opponent, which is a Markov model agent. We prove the effectiveness of our approach and the searching algorithm for the training dataset's optimal solution. In the end, we discuss the experiment result. In our game, the cards are dealt from a sure contains standard bridge deck that suffered after each round. The player is permitted to request repeated hits. The objective of player is to let the total of his card be as close as to 21 as possible without surplus. Once the player selects to stand, the game switches to the dealer to repeat those decisions. After the dealer stands, the agent whose total close to 21 without bust will be the winner. In Jeffrey's paper, the state of an agent is represented by the total of his hand cards, called soft status. The state in Markov model is a couple of each agents of the state. The edge in Markov model associated with the probability of transition between state of the heat action, which can be obtained by sampling. Using dynamic programming, we can find the probability of winning when entering a given state, from which we can find the lowest risk decision policy. To prove the effectiveness, we first build the map from uniform distribution to the true, so that we can use the uniform distribution's properties to prove that with enough train dates, the train date set's winning rate will convergent to the testing date set. To build the map, let K be the number of total possible card sequence. Using lexicographic order to sort the card sequence from smallest to the largest. Evenly divide the interval from -1 to 1 into K portions. Map the numbers in I's leftmost portion to the I's smallest card sequence. With simple calculus, we can get the following property of uniform distribution. Those properties show a sample in the testing dataset are likely to be extremely close to its nearest label in the training dataset. To prove that the average winning rate in testing dataset will convergent to the average winning rate in training dataset, we first prove that the winning rate of testing datasets where yi is a sample in the testing dataset will convergent to the set made by the nearest label of training datasets. Then we prove the second part. Let P be the probability that y and its nearest label bring different results. To prove the first part, we just need to prove that P belongs to O1 of n. Then using Chebyshev equation, we can prove the convergence of the first part. To prove P belongs to O1 of n, the boundary without function f. When the distance between y and its nearest label equal to r, if the distance between y and the decision boundary larger than r, it will be impossible that y and its nearest label brings different results. As the decision boundary is determined by theta f by the training dataset, which is independent of this y, it brings us the second expression, from which we can know the probability is less than the length of decision boundary times the expectation between y and its nearest label. As the decision boundary are mainly determined by the complexity of the model, which brings us the final results. To prove the last part, we simply use the big number theorem. In previous section, we proved the motivation to search the optimal decision policy of the training dataset. In this section, without loss generality, we introduce our approach to searching the player's optimal decision policy. For a card sequence x1 to x52, let Gx be the set of victory index. Let Boolean variable table theta be the decision policy, which map a model status to an action. Giving two status S1 and S2, we set S1 less than S2 if S1 can reach S2 by actions. With the order of status, we can assign integer to stat without changing the order of status. Now the condition of winning a particularly round-off game can be written as a closed form in Llama 5. Notice the closure BGI has two important characters. The first is last Boolean variable, the expression always not form, and the variable are ordered from small to large. Besides, the Boolean expression are exclusive with each other. When giving a collection of shoes, searching for the decision policy with highest winning rate can be reduced to a special maximum satisfiability problem. Although the original maximum satisfiability problem is NP-complete, however, in our special case, we can use gradient descent to find the local maximum solution for the flood version of such problem, which can turn into an integer solution without change the value of cost function. That gives us llama 8. To llama 8, let we start a solution found by gradient descent. If the first component v1 star is neither 1 or 0, the partial deviation of the cost function at point v star will be 0. Which means if we replace v1 star with 0, the value of cost function should remain the same.
Sorry. Which part?
Repeat
Hello?
about operation.
Sorry, I credit.
Yes, yes. Please continue.
Okay.
To prove llama 8, let we start with the optimal solution found by gradient descent. If the first component v1 star is neither 1 or 0,
Sorry, we can't hear anything.
I think he has some network issue.
I guess so. He has an issue.
Yes.
Okay.
So what we could do, sir, we can move forward.
Yes. Okay. Then we'll move forward to Dr. Sarah is not with us, didn't attend. So we'll move forward to Dr. Pavel Razumov, presenting development of an adaptive fuzzy algorithm for identifying technical channels for information leakage. Dr. Pavel, the floor is yours.
Yes. Hello, my name is Pavel. I've got a question. My session is about to start at 6:15.
We are not able to see your screen. You can start sharing your screen first.
Okay.
Yeah, it's visible now.
Yes,
Yeah,
yes.
we can see.
Hello, everyone. My name is Pavel Razumov. I want to present scientific work on the topic development of an adaptive fuzzy algorithm for identifying technical channels of information leakage. Currently, the problem of identifying technical channels of information leakage is urgent. There is no doubt that the issues of identifying channels of information leakage occupy the main position in the construction of an organization's security system. Objects of research is um, the identification processes of technical channels of information leakage when building an information security system in an organization. The subject of the research is identification methods and data processing techniques that characterize the technical channels of information leakage in the protected information system of the organization. And the aim of the whole study is to develop an adaptive fuzzy algorithm for identifying technical channels of information leakage in the protected information system of an organization. To achieve this goal, it is necessary to solve the following tasks, which are shown on this slide. The main ones are, the first one is systematization of methods for classifying technical channels of information leakage from the standpoint of system analysis. The next one is analysis of the features of fuzzy systems. Third one is analysis of the adaptability and learning, of course, of the model for identifying technical channels of information leakage. Analysis of fuzzy adaptability in systems, and development of an adaptive fuzzy algorithm for identifying technical channels of information leakage in the protected information system or an organization based on a systematic approach. Here we can see the classification of technical channels of information leakage. By type of carrier, they are divided into acoustic, optical, or radio electronic material, and material. Further, the first three of listed ones are considered. This is due to the fact that the material channel is specific and depends on the organization of the company's information protection system. And the theoretical part of the master's, let's look at the neuron structure, which is an integral part of a neural network. The structure of a neuron is shown here on this slide. The connection between neurons is carried out by synapses, which multiply the input signal by a number characterizing the strength of the connection, the weight of the synapse. Thanks to him, the input information changes when it is transmitted from one neuron to another. The output is determined by the type of the activation function and can be both real and whole. Now let's look at the neural network training and the whole scheme of training of neural network presented here. To train a neural network means to tell it what you want from it. There is some database containing examples of coefficients depending on the selected parameters of the protected premises. A learning algorithm is a set of formulas that allows calculating the required corrections for the network weight from the error vector. In software implementations, you can see that during the whole learning process, the error function, for example, the sum of the scored errors over all outputs gradually decreases. When the error function reaches zero or an acceptable low level, training is stopped. And the resulting network is considered trained and ready to be applied on the new data. The backpropagation algorithm is one of the most common learning algorithms. The most acceptable training option in such conditions turn out to be the gradient method of searching for the minimum of the error function with consideration of error signals from the output of the neural network to its inputs in the direction opposite to the forward propagation of signals in normal operation. Here on this slide, we can see the scheme of neural network training on the example of the parameter, just usual window. Let's consider each transition in detail. Number one is the input neuron, which receives the input coefficients called coef1 and coef2. The arrival of two coefficients, the input is due to the fact that the window parameter can refer both to the acoustic channel of information leakage and to the optical channel of information leakage. Weights 1, 2, 3, and 4 are synapse weights, which are set by default 0.33 for acoustic and optical channels of information leakage. Then the calculation when switching from the input neuron to the hidden neuron is carried out according to the following formula shown in the figure. When the coefficient enters the input of the hidden error, it passes through the activation function called sigmoid. After receiving all the coefficients, not only the window parameter, the coefficients are summed along the leakage channel. Next, the obtained coefficient from the hidden neuron is transmitted to the output neuron, number 5. When the coefficient arrives at the input of the output neuron, it passes through the activation function sigmoid. The calculation is made according to the formula 13. After receiving all the coefficients are summed over all channels of information leakage. Next, it comes to the comparison of the results obtained with the test data, parameters 6 and 7. If the result obtained has significant difference from the coefficient of the test data, then from point 6 we move to point number 1, changing the synapse weight only for those neurons that gave an error when compared with the test data. Here we can see a block diagram of a model for identifying technical channels of information leakage based on the coefficient method. The final result is A, which is an integral indicator of the informational content of informational leakage channel, which is calculated by summing the particular indicators and their weight coefficients, so-called informational content. The result of the decision support subsystem should be output data in the form of an assessment of the information content and recommendations for reducing information content of the identified channel. Leakage channels B, C, and D are used as intermediate data and are private indicators of the information content of sources. A set of sources of leakage channels and their characteristics are used as input data. For example, the source of the acoustic channel of information leakage, telephone and telephone communication lines, which is B1, or the source of the electronic channel computer, which is B4, can be found in more detail in our article. The general scheme of the program operation, which is more deeply indicated in our paper research.
Still have 2 minutes, sorry.
Okay, I'm gonna speed up.
Okay.
Here is the conclusion of our presentation. Summing up, I can say that me and the whole team who worked on this research We all can say that the developed subsystem will allow to identify the channels of information leakage according to the description of the premises, calculate the parameters of the identified channels of information leakage, to assess the information content of the identified technical channels of information leakage by means of a neural network, regulate weights and work results by training the neural network, choose the way the program works, a neural network or a decision support system, subsystem, to save the results or of research and recommendations for reducing the information content of the identified channels of information leakage. Edit, archive, report files, and send them by email or any other way. Thank you for your attention, and I'm open for your questions.
Thank you. Thank you very much for the presentation.
Thank you for listening to.
Of course, thanks. Any questions? Okay, then we'll move on to Dr. Nguyen Doan Dong, presenting Predicting Customer Churn and Telecommunication by Ensemble Learning. The floor is yours.
Yeah, thank you very much. Okay. Can you see it? Can you see it?
Yes, yes, we can.
Okay. So hi everyone. So my name is Dong, and I will present our paper. It's about predicting customer churn in communication by ensemble learning. Okay, wait for me. I want to full screen. Where is this? Yep, perfect. So first I will introduce and talk about the challenging, and I will talk about the proposed approach by using the ensemble learning. I will talk about the experimental setting and then the result, and finally it's about the conclusion. So what is the customer churn? Actually, it refers to when a customer stops using the service of a computer of a company, and then he or she change to the other company, the competitor. So it is report that when we try to maintain an old customer, is less, the money to try to keep it is better than try to get the new customer. It's cost some kind of 5 to 10 times to gain the new customer. So that's why the company should pay attention more on try to retain the customer. And if the company can predict the customer churn, so they can prepare some strategy, for example, like try to offer something and then try to keep them to stay in to use the service. But the problem that nowadays there are so many work on the customer churn prediction, but try to improve the accuracy is still the challenging. So our purpose is try to propose something. Here we use the ensemble method, try to improve the accuracy. So actually, ensemble learning is some kind of, we combine the with classifier of the machine learning algorithm or model, try to combine them together. And here we use the voting technique In the voting technique, we take K classification model, the classifier, and then try to train K classifiers on the training data. Here we use the weight, and then we select the weight, and then in the final result we will take the weight multiplied with the result of the classifiers results, and then we get the final classifier. So it's quite simple, and so in the experimental setting, we use the dataset from on cargo. It named telecom churn dataset in 2019, and in the dataset they already split it into 80 and 10 and 20. With the voting model, we compare with the other model. First is a logistic regression, the support vector machine, backing, XGBoost, and random forest. So we can see the chart here. This data set is some kind of imbalanced data. So with this kind of data, is very carefully, because some people on cargo, they also make some mistake when they try to get compare the accuracy with this kind of data, the imbalanced data. We should focus on the other metrics like efficiency, precision, or recall to test it, not only the accuracy. So our purpose is try to predict the churn customer as high as we can. So we focus on the recall metric. The standard pipeline in machine learning, the standard one. So in the training set, when we after we clean it or we pre-processing, we put it in the model training. In this step, we also have the fine-tune step. In here, we use the random search techniques. It a poor random tuning. Also, in the training set, we use it for tuning. For the testing set, we use it to evaluate all of the models, and then we will report this one. So here is the result. It's a result. The last one is the result for the voting. Here we'll see the accuracy 93 is higher than the other, and also the recall. The recall here, the best one is a logistics regression. However, for the other is very low. For example, like for not churn, just 69%. The 69%. So actually, logistic regression is not some kind of suitable much. Is, you can see the precision here is very low, very low. And also the SVM is the result for churn recognition is very poor, very poor. But for mapping XGBoost random forest, all of this, also the ensemble model, the backing here is also the precision is low, really low. But XGBoost, and random forest is also good. The voting here, also the recall is lower than the logistics reason, but for Northern it recognized really well. So basically, our method is not new. It's not new, but we can combine the the weak classification to to become a robust one. So predicting the customer churn is, as I say, really important for the company. So here we propose method. It's not new. Yeah, it's not new, but it can detect well on both customer churn and non-churn customers. So this method it has also the drawback is that the training is take a lot of time consuming. So however, we can it is some kind of the trade-off with time consuming and then the accuracy. So some maybe in the future we can try to tweak inside the voting algorithm, try to make it some kind of better. So thank you very much for listening.
Thank you for the good presentation. Any questions?
No questions from my side.
Okay.
And since we are running out of time, so we can just call the next one.
Yes, no problem. So we will move forward to Dr. Nasim Sadat Mousavi presenting characteristics of the Intelligent Decision Support System for Precision Medicine IDSS 4PM. The floor is yours.
Yes. Hello, everyone, and thank you very much for this opportunity. May I share my screen?
Yes, of course.
Okay. Okay. Can I start?
Yes, please.
Thank you. Okay, my name is Nasim, and I'm going to present the characteristics of Intelligent Decision Support System for Precision Medicine. This paper is prepared under the supervision of Professor Dr. Manuel Santos. I will review opportunities and challenges which resulted in proposing this framework. We will review the main objectives, definition of precision medicine, the theoretical foundation, which is about Simon's model in decision making, the feature and architecture of this framework, techniques and tools we adopted to create this artifact, the contribution or advantage of this framework, and we will finish this presentation throughout the conclusion. Why does a drug work on some patients and be less effective on others? Why does a medicine cause side effects on some individuals? Why do some diseases like cancers influence some people and do not others? Still, in the context of recent published literature, over 138,000 studies discuss about medical errors. Over 450,000 includes delayed treatment. And still, the problem of people dying from medical care gone wrong has been still not well recognized. So this is the result of a failure of symptom-driven practice of medicine, which is resulted in poor outcome and high cost of overtreatment. But also there are some other challenges like availability of patients' data. We challenge the limited human cognitive for considering all data for the timely decision making. Also, the consumerism, which is about less balance between patients' expectation and the quality of services offered by care provider. And also availability of advanced technology as an opportunity, such as business analytics and artificial intelligence, have pioneered the transformation from one-size-fits-all business model to patients like me for releasing the right medicine with the right dose for right person at the right time. Precision medicine initiated by former President of United States, Barack Obama in 2015 as a promising advancement to impact automated medical decision-making. According to US National Library of Medicine, precision medicine is an emerging approach for disease treatment and prevention, which takes into the account individual variability in genes, environment, and lifestyle for each person. In order to propose this framework, we use Simon's model and decision-making as a model for rational decision-making, which included three major phases: intelligent, design, and choice. In intelligent phase is all about scanning the environment, problem collection, problem identification, and problem classification. Design phase is about generating alternatives. It's about model formulation. It's about criteria identification. And the choice phase is it's a decision focused phase, which is about evaluating those alternatives, evaluating the consequences of those alternatives, and choosing the best option. According to that normative modeling decision making, we need predictive and prescriptive analytics, which are the advanced and sophisticated analytics in order to apply individual patients' data, those patients' data, which carry the specification of big data such as variety, velocity, volume, variability, and value, and also adopting such techniques, adopting some techniques such as what if scenario, cause-effect scenario, sensitivity analysis in order to provide the best possible treatment. So the outcome would be a suboptimal decision. Intelligent decision support system is a framework from the concept of decision support system. It's a hybrid decision support system. It's a model-driven and it's a knowledge-driven. This framework follows the concept of precision medicine. This is an interactive model. It works with proficiency. It's a contextual framework. It works with different types of data and structure and unstructured. The model is adaptive. It works based on the continuous improvement. It's dynamic to the changes. Since we projected in the artificial intelligence techniques, the model is intelligent. It includes patient segmentation and classification, and also it adopts some techniques in order to meet the objectives. So it's a goal attainment paradigm. For creating this artifact, we use different type of tools and techniques. Okay, individual patient data is important according to the definition of precision medicine, genes, lifestyle, and environmental variables. This model includes segmentation analysis to classify, to group patients according to the similar characteristics. So we use clustering techniques for that. Predictive analytics in order to predict the feature of the treatment using methods such as AI machine learning, and also in order to propose the best possible outcome, the best possible treatment based on prescriptive analytics using methods such as simulation and optimization. The contribution of this framework as a general point of view is tailoring better and economically patient-centric treatment, which positively impact the patient's treatment outcome, minimizing the medical errors, providing real-time decision support, discovering patient-specific pattern of disease progression, also allowing earlier intervention using advanced diagnostics. And it provides a platform to invite the patient as a co-researcher. So in conclusion, intelligent decision support system is a paradigm from the concept of decision support system to support decision-making tasks for releasing the best possible treatment for the patient, for the individual patient. Successful adoption of precision medicine has been found in tailoring the treatment to particular patients group based on the common characteristics. The failure of traditional business model of one-size-fits-all and availability of healthcare big data and also technological advancement have motivated this transition. The major benefit of this clinical practice is saving more lives, increasing the quality of treatment, decreasing the boundary between health and diseases through the multidisciplinary cooperation platform. Intelligent decision support system for precision medicine is designed by projecting particular techniques and tools and equipped with specific characteristics to propose the suboptimal outcome. And I'm going to, my presentation is finished, and thank you very much for this opportunity, and I'm available for answering any questions. Thank you.
Thank you. Thank you for the informative presentation. Any questions? Okay. No questions, then we will move on to Dr. Peter Lukac, presenting confidence prediction-driven iterative data annotation. The floor is yours.
Hello everyone, good evening. Yes.
Yes, please.
I can continue. Just a moment, please.
Yes.
Okay. Confidence prediction drive confidence prediction drive iteration data annotation. Existence of large datasets such as ImageNet plays crucial role in development of novel algorithms and revealing new, often unexpected challenges. Necessity to obtain large amount of labeled training and testing data is very often the main obstacle for solving many important problems in real environment. Making dataset is financially expensive, time consumption, and human experience are requirements. In this paper, we are interested in the problem of ground truth dataset creation, specifically how to accelerate it. We tested two data annotation strategies to create ground truth dataset called high confidence and low confidence. These strategies tell us what key is used for selecting samples for unlabeled data. In HCA strategy, we select samples from highest predicted confidence. On the contrary, in LCI strategy, we select the samples from the lowest predicted confidence. We evaluated these strategies on the two datasets, specialness and CIFAR-10, based on three criteria: number of all annotations, number of complex annotations, and computing time. When we annotated unlabeled data, two situations can occur. In this first case, when predicted data have right label, then we say about easy annotation because annotator only check if label is right. On the other hand, when data have wrong prediction, annotator must select right label for sample what is more difficult task than say if label is wrong or right. We call this complex annotation. Computing time is time needed to annotate the whole dataset. It is sum of number of training samples multiplied by number of epoch in concrete iteration. Both strategies are compared to baseline method, which is based on random annotation. We train the classifier on a random subset of training data and compared its result against proposed strategies. The annotation process is iterative. In each iteration, classifier, training, and data annotation is executed in sequence. Firstly, a classifier in form of convolutional neural network is trained on all currently labeled data. Next, forward pass is executed on unlabeled data to compute a predicted confidence score and candidate label. This predicted confidence score is used to select new data for annotation. Finally, selected samples are manually annotated and then used to train new classifier as process continues. Firstly, we need to select parameters for datasets. The first parameter we need to select was number of samples in training at the beginning of annotation process. Figure shows results for random strategy using different size of testing dataset, 1%, 2%, and so on to 20%. And subset of training data, 500, 1000, 2000, and so on to full dataset. Large testing set yields better results, but the difference in accuracy are rather small, and current trend is same in all cases. Hence, we selected 1% of the most efficient amount and used it for all other experiments. Next, we needed to set parameters for LCR and HEA strategy, the number of annotated data per iteration. We evaluated different amount of annotated data per iteration and fashion list dataset on fashion list dataset. In figure are reported results for 500, 2000, and 4000. Our settings were performing similarly well in terms of all annotations and complex annotation criteria. We set the parameter to be 2000 annotations per iteration because parameter 500 requires too much computing time, as you can see in the bottom figure. Parameter 4000 performs slightly worse performance than 2000. The main experiment aims to evaluate the efficiency of proposed strategies. We use random as baseline strategies, as it's commonly used to approach to create small to mid-sized dataset. The strategy which can reach higher accuracy within the same amount of work is considered to be better. It should be noted that at the end, when all data in fashion list and separated dataset are annotated, all strategies have to obtain the same result since the dataset contains the same data. We can see similar trend for both fashion and separated dataset. LCI strategy performs the best for all annotation criteria. Therefore, it is most suitable in case where simple and complex annotations are similar in terms of human labor. On the contrary, HEA strategy is the best is based in complex annotation are much harder to carry, where complex annotation are harder to carry out. This is often the case in tasks with high number of classes. Naturally, random strategy perform best if computing time is the main concern. Random strategy does not require any classifier to be trained. And for this reason, computing time is 0. LCI strategy is computationally more efficient than HEA, especially in case of fashion list. We use standard image transformation, horizontal flip, translation, rotation, and scale to test the effect of data augmentation in process strategy, in proposed strategies. Here we train 2 classifiers in each iteration, with or without data augmentation. Classifier with data augmentation is used to select samples for annotation. Classifier without data augmentation is used to report the accuracy. This allows us to fairly assess the quality of data set as such and to compare results across all experiments. HEA strategy benefit from augmentation data, especially in terms of complex annotations. Data augmentation helps to train a classifier which is more accurate. Therefore, it produces also more precise candidate label precision for. Therefore, it will produce also more precise candidate label prediction for samples with high predicted confidence score. This seems to have the adverse effect on LCA strategy, where samples with the lowest predicted confidence score are selected. Thanks for attention.
Thank you. Thank you for your presentation. Any questions? Okay, no questions.
Yeah, we are not asking much questions because we are running out of time. But
right.
however, let me congratulate all of you for presenting such nice papers. They all were very nice papers, knowledgeable, and I think definitely the others who are listening those papers, they will take some ideas to improve their research work. So let me congratulate again all of you.
Thank you, sir. Thank you for your presence for the end moment. At the end moment also you were present.
Thank you so much.
Chair the session. Thank you so
I
much.
sincerely thank all of you, all our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international congress. I hope this session was informative and knowledgeable as well. All the presenters would be getting their digital certificates through mail within 2 working days. Further, all the papers have already been sent to Springer. The publication will be live within 4 to 6 months. Kindly cooperate with the team of ICICT 2021. I also thank our session chair, Professor Vinjay Singh Rathore, for chairing this session. A token of appreciation to the chair on behalf of Team ICICT 2021 and Global Knowledge Research Foundation. I kindly ask you to put on all your cameras for a snapshot for the virtual conference. Thank you all. Take care and stay safe. Thank you.
Thank you.
Bye.
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 Bye-bye, all of you.
Bye-bye.
Bye.
Next time we'll definitely meet.
Hopefully, yes.